So the easiest thing to do is just look at peak torque here.
Uh-huh.
And we know that right around 6,500 RPM, torque really starts to build rapidly.
Okay.
So we want to protect you in that area, as well as we want to protect you all the way up to just over peak torque, which is around 10.5.
Right, okay.
From there, it starts to sign off, and it's not so abrupt.
Okay.
For a street rider, that's all we really worry about.
Okay.
So the general rule of thumb that I go by is you're going to be somewhere between 10 and 20% of throttle when you start to ramp yourself up, throttle and RPM through that section.
Okay.
So I'll go back and I'll create a little TC map starting in that area and going up, and we'll put things like 5s and 6s in there, and then as the torque starts to level off between 8, 9, and 10, we'll start to back those numbers down to 2 or 3, because it doesn't need to be as intrusive because it's not as violent of an increase of rate of change.
Okay.
How's it cutting power to the wheel? Is it
ignition?
So it's not using
touching
any kind of mapping or anything, it's just cutting ignition.
It's just cutting ignition.
It's cutting it. It's not just advancing it, or
no, it's cutting it.
Oh,
it's
all
it's
cylinders
cutting
or
the
just
pulses. Yeah, and it depends. You know, I mean, and I don't know. I'd have to ask Amar to be 100% sure. I don't know if when it's on a lower setting, it only cuts pulses to 1 and 4, and you know what I mean. I don't know if he has it programmed to cut 1 and 4 at lower speeds, or lower gains, and all 4 at higher gains. I'm not quite sure how he has his system.
Normally, like the other ones compare wheel speed, right?
On production bikes, they do, but that's it's a pretty complicated thing. You know, there's.
Well, this couldn't have been no picnic either, but I guess the next step would be much more. I guess wouldn't be that affordable to average rider.
It's really not, and then you have even bigger problems with the end consumer, because how do they set something up where you have to teach them about variables of front wheel speed versus drive speed versus driven speed? You know, because now you have a driven speed, you have a drive speed, you have a front wheel speed, and oh, by the way, your front wheel just got light. So the contact that it had on the ground just increased its speed. Right? You do a wheelie, whatever. There's all, you know, like in our race bikes, we end up with telemetry. And so when the boys have a wheelie, obviously it affects the front wheel speed. So we have to make sure that we cover those areas so that it's not cutting power just because it's a power wheelie. Conversely, there's tracks that we go to where they're going uphill, like Road Atlanta. And sometimes the rate of change of the front fork height, you know, there was times where the boys said, man, the thing feels like it's down on power. Well, because the forks were extending going up the hill, it thought it was wheeling, and we had it set to control the wheelie. Well, so it can get very, very complicated. This is...
many parameters to monitor.
Yeah, this is already pretty complicated for the end user.
Is it pretty usable, do you think?
Yeah, I think so. Like I said,
for a club racer or something, it's a viable system.
Yeah, it's a good little system. I mean, like I said, for what you're doing with it, I'm just going to set it up so that it kind of covers you. I don't expect you to go out there and go, hey, let's see how this works, and pin it and hope that it's going to save your butt.
That's his doing.
I won't be doing that.
So 0 happens to be the middle of that switch. We discussed this, I know, but it literally goes from off all the way to the left to -5 to -4 to -3, -2, -1, 0, and then +1, +2, +3, +4, +5. So,
why does it do that?
It's to give you a gain without having to have a laptop. So if you're out riding and let's say the map that I make, you go, wow, that's just way too intrusive. You can turn it all the way down, or you can even turn it off. If you are having a runability issue, just turn the thing off and see if it makes a difference.
How do you turn it off?
All the way to the left. So this is, you know, the peak torque that we were looking at. And so what I'm trying to do is just build a safety map around that same peak torque.
Right.
So if you get aggressive on the throttle, that it's there, but it's not intrusive. Peak torque really starts to ramp up right around 6,500, 7,000 RPM, right? By 95, it's leveled off. So if you look, starting at 6,500, from 10% of throttle up, I mean, basically what I did is I made it come in pretty aggressively, and then I taper it off. Same thing, I don't have a whole lot up there.
Those numbers are out of 10? Out of
a scale of 10, yeah. And I taper it off the higher you get in the throttle percentage, because usually by the time you get to that higher throttle percentage, you've already way gone past this RPM.
Right.
It's you know what I mean? On the dyno I can do it, but in real time for you guys to do it, I mean,
Sure.
you should be at the track. So, but anyway, you can see that we put this in here to try and grab the thing as you're accelerating from 20 to 60% of throttle, where most guys are really coming out of the corners and getting happy with the throttle. It's there so that it's a little bit intrusive, so that it'll help you, and you know, as you're coming up on peak torque, which is where the rear end really wants to light up. But as you get further out, we have just little numbers in there to hold it, just because it's probably you've already gone past it and you've already gotten past the peak torque part of it. So you've gotten past the scary part where the rear end wants to go, yeah. So that's what we did.